Okay, hopefully you got bell work done. This is some Algebra 1 stuff. Hopefully you remember a little bit of it. Sorry I'm not here. My wife had a doctor's appointment changed, and it's a sonar of our third child, so I really wanted to be there, and I didn't know until about 11 o'clock this morning. So sorry about the late change. We're going to learn on the video here today and see what we can do. Mr. Shannon and Mr. Hessian are both very smart. If they need to help you, they can. Find the slope between these 2 points. So if we've got 2 points, we've got slope formula. This should be pretty straightforward. X sub 1, y sub 1, x sub 2, y sub 2. We're plugging in. So 13 minus 5 over 4 minus negative 2. You plug them in and you do it. 13 minus 5 is negative 13 minus 5. Geez, I'm already off to a bad start. Negative 18. And 4 minus negative 2, that would be 6. Negative 18 over 6 is negative 3. That is my m, that is my slope. It says now write the equation of the line using point slope formula. So remember, this is point slope formula. In the end, we want to get it in the form y equals mx plus b. Remember, to do point slope formula, you need a point and you need a slope. I've got the slope, and I've got 2 points up here to pick from. I just need to pick one. So I'm going to pick the easier number. So this one right here. So it's y minus, x minus. Plug in my slope. My slope is negative 3, so that goes in there for m. My point was negative 2, 5. So in for my y value is going to be 1. In for my x is going to be negative 2. Minus the negative, so I'm going to change my signs. Y minus 5 equals, distribute, negative 3x minus 6. To finish, add 5, y equals negative 3x minus 1. Please pass out the note paper that I've left on the desk for them, 5.2, and hit spacebar so you can pause it as you pass them out. Okay, so we're looking at notes now. We're on the front side here, fitting a line to data. So we're making best fit lines today. Okay, we're going to go through the fast version of this. Tomorrow we'll do it a little bit differently. So we've got these things right here. These are going to be ordered pairs, and we're going to graph them on our graph over here. So I'm going to go to negative 2, 4, and make a dot. Negative 1, 3, make a dot. 0 and 2.5. 0.5 and 2.5, 1 and 2, 2 and 0.5, very exciting stuff here, 2.5 and negative 1, 3.5 and negative 3, 4 and negative 2.5, and 5 and negative 2.5. There's our dots. What we're going to do next is make a best fit line. A best fit line is a line that best associates or correlates our data. So I'm going to say it not perfectly here, but I'm going to draw a line. These dots obviously look like they're in a line. I'm going to draw a line that represents our data the best. So something that goes right down the middle of it there the best I can. So if you notice here, I've got some dots like this one and this one that are down below. This one's down below. I've got 1, 2, 3, 4, 5 up above. Those two seem to be right on it. That's pretty good. Maybe not perfect. Maybe it'd look a little bit better if I did this or something like that, but it doesn't matter. We are estimating the best we can. Once we've drawn a line that separates our data, I would definitely want it to be a straight line. So either use your ID or something like that. Once you've done that, we're going to look at this data and try to find where I intersect the graph the best. So as I look at my graph, I'm going to look for a place where my pink line intersects a grid mark the best so I can make a good ordered pair. So right there, I'm off a little bit. So that one's not a very good choice. I'm going to look for a better one. That one's pretty good. It's not perfect. That one looks even better. So this spot right here looks like a good ordered pair. It is the ordered pair 1, 1. It intersects my line pretty good at a point. Now I'm going to pick another point, and this time I'm going to try to pick it as far away as possible. So I'm looking for another place, preferably not next to that one. So if I look here, that one's not perfect. Just for the sake of ease, I'm going to change that line a little bit. Hey, look, now it's pretty perfect. That ordered pair is at -4. I'm sorry, I can't make ordered pairs. That ordered pair seems to be at 6, -4. That seems to be a pretty good representation. Once I've got two ordered pairs that fall in my line, I'm going to do the same thing we did in bell work. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it is -4 minus 1 over 6 minus 1. -4 minus 1 is -5. 6 minus 1 is 5. -5 over 5 gets me -1 as my slope. So there's my slope. Once I've done that, then I'm going to write the equation of the line. It's y minus x minus. I'm using point slope formula. I'm plugging in my y value, which in this case, or my slope value. My slope value was -1. My line is going downward. That makes sense. That has a negative slope. And I'm going to pick an ordered pair that I used up here. So I'm going to pick the easy one here, which is this 1, 1 point. I'm plugging in 1 for my y and 1 for my x. And then I'm going to get y by itself. So distribute. Plus 1. And then to finish this thing, I'm going to add 1 to both sides. Y equals -x plus 2. You might not have the exact same thing I had. Maybe for your slope, you might get a decimal, but it's a close approximation of what we're trying to do here. Okay, so there's my answer, y equals -x plus 2. Remember, this 2 right here is my y-intercept. So if we're just estimating, you could really just look at this graph and be like, hey, look, I'm pretty close to 2 right there. I'm guessing my y-intercept is going to be close to 2, and that's what I'm trying to do. All right, so next one, we're doing the same type of thing. It says the table to the right gives the number of hours spent studying for a science exam and your final exam grade. So this row of numbers right here is going to be how many hours did the kids study for the test, and this is what grade they ended up with. You can have a good idea in your brain. If you study more, think about what's going to happen to your grade. But let's look at this. So the first thing we got to do is make a scale for this chart. So if we look at this data here, these are our x values, these are our y. Our x values go from 0 as the smallest number to 5 as our biggest. So on our scale, we're going to go 0, 1, 2, 3, 4, 5. We make a good scale. Everything fits, so we're good to go. Then we're going to do our grades. So our grades go from 60 up to 92. So these are our grades. 60 to 92. So this is, if you notice here, none of the data really happens between 0 and 60. So it doesn't really matter where that's going to be. So what I'm going to do here is I'm going to make a jump here. Okay, so if you notice there's like a little break in the line right there. It's saying basically skip all the information we don't need. So I'm going to go to 55 here to start, and then I'm going to count up by 5. So 60, 65, 70, 75, 80, 85, 90, 95, 100. Again, all of our information's on there. It's nice and spread out so we can see everything. Next thing we're going to do is plot our data. So take a second here. Whoever's in charge of my class, please hit the space bar for a second and let those kids plot those points. All right, so after we've plotted our data, we've got these points here. Our next job is going to be drawing a best fit line. So using that information we have, we're going to try to draw a line that would best represent our data, where it balances the same amount of information on top and below. Do your best. Draw your line. Okay, I don't love that line. I might move it around. Take a second here, use a straight edge, and draw a line that separates your data evenly. Hit the space bar, please, to pause it. All right, so there's my best fit line. It's not perfect. Again, this is an approximation. Once we've drawn that best fit line, it's your job to find 2 places where that graph intersects, or your line intersects the graph. So again, you're zooming in and looking at those points, and you're trying to see where does this red line cross an intersection point pretty well. So right there, there's a pretty good one for me. Mine is right there at 275. I want you to find your own. Okay, looking at your graph, try to find those points for me. Go ahead and hit the space bar. So I found 2 points. I've got 595 and 275. I had different points earlier. Those are the ones that work for me right now. So you might have something slightly different. That's where mine are. Okay, so once I've done that, I'm going to write the equation of the best fit line. So for me, I'm going to write y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm doing slope formula. So 75 minus 95 over 2 minus 5. I get negative 20 over negative 3, or my slope is 20 over 3, positive. For just this one time, we don't do this a lot, but in this case, I'm going to go ahead and get a decimal here. So in my calculator, I'm going to take 20 divided by 3 and see what we get. So just that way it's easier to compare our data. Let's look at what my fraction really becomes. So 20 divided by 3. My slope is 20 over 3, or you could say my slope is 6.67. So find the slope of your line. So whatever 2 points you have, find the slope of them, and then look at the decimal. See if your decimal makes sense for your information. Compare around, check with your neighbors, see what they got. You probably should have a number somewhere between like 5.5 and 9 at the very biggest. It's probably better if it's pretty close to 7, but anywhere from 5.5 to 9, you're probably doing the right thing. It just kind of depends on your data. But I got 6.67. The next thing we're going to do is write the equation of the line. So I'm going to cheat here. All right, I wouldn't do this all the time, but y minus, x minus. I'm going to plug in my slope of 20 over 3 and my point. So I'm going to pick one of these points. I'm going to pick 2 and 75. So it's 75 and 2. I said I was going to cheat. I just changed my mind. So I'm going to do this the right way. It's not real hard to do. All we're going to do here is distribute that 20 to the right side and distribute that 3 to the left side. If you remember doing this back in week 1, we wrote equations of the line. So I got 3y minus 75 times 3, 225, equals 20x minus 40. And then I'm going to solve here. So add. Divide by 3, divide by 3, divide by 3. Y equals 20 over 3x plus 165 over 3, or 185 over 3. Again, this is a y-intercept. So if I look at my graph, I probably could have estimated this pretty evenly as well. We did it the long way, but if I would have cheated here, I would have looked at my graph and said, hey, look, here's my line right here, this red line up here. Where does it intersect the y-axis? That's what number is going to be tagged on the end here. I'm guessing whatever I get in my calculator here is going to be pretty close to 62. Let's look. 185 divided by 3, 61.67. So we were pretty close there. Is it perfect? No, we estimated, but that's the equation of my line. We're still on question 3 because I haven't answered it yet. It says, predict what the grade would be if you studied for 6 hours. So this is my prediction equation. If I want to know what it is after 6 hours, that's like what my x value is going to be at 6. So all I'm going to do here is I'm going to take 6 and I'm going to plug it into my x. So in my calculator, I'm going to take y equals 20 over 3. I'm going to plug in 6, so times 6, and then I'm going to add 61.67 on the end. Add them in, hit enter. I get 101.67. And again, this is a percent. That's what percent I would make on that test if I studied for 6 hours. Does it make sense that this line could last forever? Okay, we're doing some information here. We've got this answer. Can I extend this line for 10 hours and 12 hours? Would it make sense? Hopefully you're saying no. If your line keeps going up and up, eventually you're going to hit like 300% if you studied for, whatever, 45 hours. Well, that's not realistic. You're not getting a 300% on your test. So maybe this line made sense for a while, but eventually it's going to flatten out, and you're not going to get above 100% because you can't get bonus on every test. But that's the idea. It helps us to model and predict what's happening in the future. We're almost done. Last thing we're going to talk about is correlation. When we use the word correlation, it means how well do the dots relate to each other. So if we look at this one, this first one is called a linear trend. When you think of the word linear, hopefully you're thinking the word line, because with these dots right here, I pretty easily could draw a line there. You could have a non-linear trend. If something is non-linear, that means it is not a line. These dots are still correlated, but it doesn't make sense to draw a straight line here because they start to bend. Just like in the problem that we just did, it would make more sense to make a curved line. So if it's not a straight line, then the trend is considered nonlinear. You can have a positive association, like the more hours you spend studying, the better your grade is going to be. As one thing goes up, so does the other. Your graph is going upwards. Okay? Or you could have a negative correlation. If things are related negatively, the time you spend at the mall and the money you have. The longer you spend at the mall, the less money you have. It has a negative correlation. Your graph is going downward. You have a negative slope to your line. You can see a strong relationship. So looking at this graph, you can see a strong relationship because these dots are really close together. It's a really easy line to make. Or you could have a weak relationship. Like looking at this graph, those dots are all kind of scattered around there. This line kind of makes sense, but so does this one. And so does this one. It's not a perfect line. It's a lot harder to draw a best fit line on that graph if it's a weak correlation or a weak relationship. Flip it over to the backside. No, we're on the backside. I changed notes. Never mind. So looking at the scatter plot with this data, which one could be best modeled by a linear function? Okay, so I'm going to ask you to be grown-ups and actually do this. If we numbered this 1, 2, 3, and 4, think about it. Which one of those graphs, 1, 2, 3, or 4, has the best, the strongest linear correlation? So you don't have to hold them straight up in the air, but kind of hold them out in front of you. Look at your neighbor at worst and think 1, 2, 3, or 4. Which one of those has the best correlation? Hopefully you're saying 4. To me, that one's the best correlation because it's the easiest one to draw a line on. Think to yourself, is that a positive or a negative correlation? Hopefully you're saying negative because it's going downward. Now we're focusing on these 3 graphs. That one's the best. Now looking at the next 3, 1, 2, and 3, think about it. Which one has the second best correlation? Hopefully you're saying number 2. I think that one's the second best. You can draw a line pretty well in there. Now where that line may go might be off a little bit, but it's the right idea. The second graph there is the second best one. And then the last 2, and I would probably say the third one's the next best. You could draw a line like that and get the data pretty close, but to be honest, you could probably tell me, hey, your data's doing this, and I would say that that one's not awful either. I would say, yeah, sketchy, but maybe the third one. The fourth one here would be number 1. I would say that this one has no correlation. Those dots are just in a random blob. I can't really see anything that connects those dots together. So sorry this wasn't the perfect lesson. Hopefully you pick up a little bit. We'll continue tomorrow. Tomorrow we'll do a little bit more with graphing calculators. For the rest of the period, all you're doing is working on that last graph there on the back side. Graph those dots and then find your best fit line and write the equation of that line. If you did not take your test today, you'll take it tomorrow. Sorry.